The topic I am just going to cover is about the overall overview of the solid waste management practices. Mostly we have been working mostly with respect to leather industrial waste, and to some extent we also have gone for a lot of work in municipal solid waste also to some extent. And I'll just give you overall view of the works that has been carried out by us and what are the current strategies, how it is being proposed. So if we come to the solid waste, I think you had a couple of presentations earlier also. I hope by the time now we got an idea about the solid waste. So the solid waste main categories we can include this three. Municipal solid waste, that is mostly generated from the domestic activities, mostly from the urban cities or semi-urban areas. Even rural areas, we get the municipal waste, that is from the domestic activities, mostly coming from the household activities, and to some extent some commercial activities within the urban area. That comes under the municipal solid waste. So we have our municipal solid waste rules 2016, which talks about how to manage this municipal solid waste. Then we have another one, that is industrial waste, industrial solid waste. The industrial solid waste, we have two categories. Especially, you can say that the solid waste is categorized into non-hazardous and non-hazardous. So we have a hazardous waste rules that has come way back in 1989. First rule that has come after the accident in chemical industry, where actually they generated a lot of hazardous waste, and they have to dispose it of. At that time only the industry country has come across hazardous waste generated from the industries, and the new rule on hazardous waste came in 1985 after the accident, the Bhopal accident in 1984. And non-hazardous waste, actually the from industries also we have some waste which are not categorized, which are not covered under the hazardous waste rules. So hazardous waste rules actually talks about the categories of waste that is coming from industries based on the toxicity, based on the humidity, based on the activity and other parameters. They have identified a different hazardous waste generated from the industry. So in the hazardous waste rules, they are given a Schedule 1, Schedule 2, and Schedule 1 talks about the list of hazardous waste generated from the industries, and the industries waste from that category and from that particular location is also identified. That identified location waste is categories hazardous waste rules as per hazardous waste as per the Ministry of Environmental, Forest and Climate Change. Now we also have some amount of solid waste generated from non-hazardous waste generated from industries. For example, we have some solid waste, organic solid waste, mat, which is not hazardous, which is not covered by the hazardous waste rules. Then it is non-hazardous waste. So this is the industrial waste that is coming from the industrial activity, mostly the industrial operations. Then the other category that is recently that is coming up is that has been already issued here is the biomedical waste. So the waste generated from the hospitals, especially the surgical operations and everything, we have all the biomedical waste generated from the hospital activities. Even within a hospital also we have different categories. Different color coding is given for that, and different methods of. We also have biomedical rules which talks about how to manage the biomedical waste generated from the hospitals also. So what I'll do is in this presentation, I try to cover something about hazardous waste and to some extent about the municipal solid waste, and based on our expertise. So if we go to the municipal solid waste, that is, I think most of you are aware of that. We have a generation. The generation of the waste is also an issue, and depends on approximately 0.5 kg of waste is generated per person per day. And this 0.5 kg is an approximation, and it depends on the status of the people. For example, in a commercial urban area, like metropolitan cities like Chennai, Mumbai, Delhi, the waste quantity will be more because we will have a lot of packaging, things like that. But if we go for a small towns, medium-sized towns, then it may not be that much, 0.5 kg, maybe little less, maybe 0.3 or 0.4. If you go to rural area, still it may come down, so 0.1 or 0.2. So that depends on the status of the people, and depending on the living status of the people. That actually varies. And this waste, because of the packaging and other health hazards related issues, the waste generation is also getting increased, and it is expected that it will be double by 2025, because the way in which we are using our packaging and other things for our food and materials which we use, the waste generation will be double, and even the characteristics also will be little different. As of now, it goes for the mostly it goes for the landfills, landfilling, or open landfill or open dumping, or landfilling, secure landfill, or some to some extent it goes for composting. They develop the micro composting processes within the urban area, and some amount of waste is also going for composting, and so a small amount of waste is also going for biomethane. So major is landfill and composting. So if you come to the major problem faced by the country, not only India and other countries also, so one is the energy demand. So there is always an energy increase and ever increasing, and always a gap between the demand and supply with respect to the energy. So conventional source of energy are coal-based, petroleum-based products, hydro projects, nuclear projects, and we also started recently renewable, and it is also doing a good amount of potential solar, wind-based, tidal, and biogas-based. So these are the sources of conventional and non-conventional source of energies. So this energy is always there is a demand. Actually, we are not able to meet all the requirements of the energy. On the other side, as I mentioned, is a municipal waste. Actually, not only the municipal solid waste, but other industrial waste also generated. And this waste, as of now, the major problem is with respect to the segregation. This waste is a mixed waste that is coming from the domestic activity. If it is a segregated waste, if the waste that comes from the domestic itself is segregated into paper, plastics, or into the organic waste, then it can be very well can be handled and efficient. So that is one issue, segregation issue. Another thing is generation. Generation is also increasing. I was mentioning here. The generation of waste is also increasing. And the treatment disposal is because when you have a mixed waste, we don't have any treatment to handle the mixed waste. That is the problem. So, for example, even if you say that you can go for incineration, incineration can handle, but actually, if you take a wet waste, organic waste, wet waste, it will not be suitable. If you have a lot of inerts, then it will not be suitable. Then we have to find a suitable option of treating this waste. So if potential, actually, we have also another waste that is called the bulk waste. For example, you can even the domestic activities. For example, if you go to urban area, still we have some slaughterhouses. Slaughterhouses means where actually the animals, small, large animals are kept, where actually you get a considerable amount of solid waste. That is mostly the what do you call as cow dung, undigested material coming from the stomach, and also some amount of unedible portion of the animal is also wasted. That is the slaughterhouse waste, and even some, to some extent some blood is also wasted. So these are the waste that is generated from bulk generators. Actually, it's organic waste and it's bulk generator. Then we have a chicken shops. Now we have a chicken shops everywhere, and we have a considerable amount of chicken waste coming out from the different industries. And fruit residues, actually from the market, vegetable market, we have the fruit residues coming from the shops or things like that. We have a residual waste, and also the waste that is unutilized fruits also comes as a waste. Fish processing or fish markets, that is also another potential area where we will touch the amount of waste. On poultry waste, actually now in the outskirts of the areas, we have a lot of poultry activities that is going on, and that also generates considerable amount of animal birds droppings. That is a poultry waste also potential waste. So as I mentioned, there's municipal solids has different categories. Small towns 0.1 to 0.2, medium towns 0.3 to 0.4. Large cities it is 0.5 kg per capita per day. So, and as I mentioned that this treatment method, sanitary landfill, aerobic composting, incineration for a mixed waste, something is being tried now in Delhi and some metropolitan areas. Incineration is also being attempted to smaller extent. Anaerobic digestion is biogas systems. and the pyrolysis is small to some extent that has been initiated. These are the different treatment methods that are available for municipal solid waste. So most of the places actually, as of now, it goes to the dump site or open dump sites. Actually, when it goes for dumps, actually there will be a lot of people, and also they try to take the valuables, recoverables from the waste. And when you dump this waste, what happened? Actually, we are thinking there is nothing problem. One is actually the groundwater contaminations happens, and also during the rainy season, and also this waste, organic waste, when it is subjected to biological reactions, it emits methane and CO2 to the atmosphere. So it's called greenhouse gas emissions. So the landfills or open dumps also create a lot of emissions, greenhouse gas emissions, which are the greenhouse gas are responsible for climate change. So, as I mentioned, the municipal solid waste, as of now, we are not taking it that much seriously. If this waste is not handled properly, it will have a lot of serious repercussions on the environment. One is global warming also. The global warming, I think everybody is aware of it because of the increase in the CO2 and methane composition in the atmosphere. So the part of the sun rays reflected back is absorbed by the greenhouse gases, and this have a lot of effects on the overall globe, air especially. So I think we must be aware of all the trends, what is happening. I think everybody is aware of the greenhouse gas emission trends and how it is increasing with respect to from early 90s to 2000, and it is expected to further increase by 2050. Up to 2050, it will be increased. So this global emissions, part of that I'll explain that this is not only because of solid waste, it's overall emission levels, and in that how the solid waste is contributing for that. So this is the global temperature, average temperature Earth surface, how it is increasing with respect to earlier years. There is always a trend from 1950 onward, 40 onwards. There is a continuous increase, and this linear trend is having a lot of effect on the environment. And you can see this warmest years. You can see here, so the warmest years in the recent past. And actually, how to mitigation, and one is mitigation measures. For this is different. You can go for different measures like power generation, transportation. All you can go for different fuels. There, actually, we can see that controlling greenhouse gas emission depends on clean technology, fuel switch. That's where actually the power generation plants actually we have to look for alternative fuels, and industries and transportation. So how this solid waste can help in mitigating these measures? For example, if the solid waste is disposed in the landfill, it emits. If the same solid waste, if it is used as a for a power generation, for example, if you put a power plant, installation facility, and if you use this solid waste as a raw material, then it can become a source of power generation. So that is where actually now the hazardous waste as well as municipal solid waste, the solid waste which are having calorific value, the segregated waste, it can be given as a source of fuel to the power generation and industries. Especially as of now in Tamil Nadu, other places, the hazardous solid waste, if they have a calorific value, then it is sent to the cement industries, and also it is sent to the other industries where actually there is a need for fuel. That purposes is being used. In the transportation sector, how the solid waste can help. Actually, in the transportation sector, we mentioned that one of the method is anaerobic digestion process. The anaerobic digestion process we get the biogas. So the biogas can be used for public transport or urban transport system, so that the fuel, the conventional fuel is replaced by the biogas. So that will reduce your emission on the environment also, and in addition, the air pollution also will get reduced drastically. That is the alternative methods by which we can control the greenhouse gas emission. The mitigation measures also can be taken care of, or as well as the solid waste also can be taken care of. And the energy conservation measures, that is the alternative measure. And reduction of emission for open dumps and landfills. Actually, it is already dumped. Open dump is there. It has been for quite some time. And in that areas, what we can do is we can go for closing of the open dumps and collect the gases, the emissions, whatever that is coming out can be collected, and that can be utilized. So that is how it can be done. And sequestration of greenhouse gas is one of the other methods. So as I mentioned, we have the energy crisis on the one side and the waste problem on the other side. So actually, depending on the methods, best solution is we go for a waste to energy projects. Actually, if you go for waste to energy, the energy will be getting it, and the waste problem is also solved, and the greenhouse gas emission also to some extent that will reduce. So this waste to energy, we have a different method. One is the thermal method. Thermal method, actually, if you go for energy, only the dry fractions of organic fractions of solid waste can be taken care of. If you have a wet waste, then it will not be suitable thermal. So the wet waste, if it is there, it can go for wet fraction can go for another digestion process. If you go for thermal, we automatically get the heat energy that can be used for power generation or direct heating. Or if you go for anaerobic digestion process, you get the biogas, that is a methane content will be there. This methane can be utilized for generation of power. So the best solution to handle the waste as well as to solve the energy problem, this methods can be approached. And this also indirectly, the energy problem is also solved, the waste is also treated, and also the emission of greenhouse gas from that also can be reduced. So we'll have a win-win situation for the solid waste energy. When it comes to the biological treatment process, I mentioned anaerobic degradation process, where organic fraction, organic pollutant is there. When it is subject to anaerobic degradation process, you get the CO2 and methane. When you have this CO2 and methane, there's anaerobic treatment process. As I mentioned, this is one best solution for waste energy anaerobic treatment process. So in this anaerobic degradation process, actually the biomass, what we call as a bio waste, whatever is the biodegradable waste, food waste, kitchen waste, slaughterhouse waste, vegetable market waste, all the bio waste can be subjected to the anaerobic degradation process. So we have a different steps. There are different bacteria involved in that. So the first is hydrolysis steps. Then we have astrogenetic bacteria which work on the biomass, convert into acids, and this acid is converted to astrogenetic bacteria by acetic acid, and the acetic acid is converted back to biogas. Here also some bacteria will get converted into acetic acid directly, and the acetic acid is converted by methanogenic bacteria, the blue bacteria, this blue color bacteria, so bacteria we convert into methane. So these are the steps involved in the complex degradation of biomass. Whatever will be the biomass, the end product is biogas, and depending on the composition or the characteristics of the biomass and the quality of the biomass, the amount of biogas will be varying, and the time duration taken for degradation also varies. So these are the major degradation step that is happening in the biomass to biogas. And during the process, what are the other factors? For example, if you do an anaerobic digestion process in a reactor, there are different parameters by which we have an effect. The major factor that affects the anaerobic degradation process are organic loading rate, hydraulic retention time, what is the retention time in the reactor, and temperature and pH of the reactor system. So these are the three major factors that have the effect on the anaerobic degradation process. So when you go for anaerobic degradation process, what are the advantages? So when you go for anaerobic degradation, we have the energy, as I mentioned, the energy and economic benefits. Because the energy, if we get energy out of it, the biogas, whatever the methane that is collected, is used for energy purposes. Then you get energy generation from that, and you have also have some economic returns. And what are the this anaerobic degradation process has potential to create a wet fraction. Wet fraction means whether the food waste or canteen waste, or we have fruit waste, all have a lot of moisture in it. More than 80% will be moisture in it. So this waste cannot be taken to the incineration facility. So this is so that for wet fraction. Potential to economics to benefit from higher energy prices. This actually in future the energy prices are going to be higher, and this process will have a better price in the future. If we go for environmental benefit, in addition to that, I mentioned about environmental benefit. It's an environmental sound treatment process. That means we are having a treatment system where it is completely safe, sustainable. So that is the advantage of this biological treatment process, anaerobic treatment process. And what we have is a recycling benefit. Recycling benefit in the sense you get the compost after degradation process. You get the digestate or the compost that can be used as an organic manure. So that is the additional advantage of this biological system. And the land requirement for this anaerobic degradation process is comparatively less when compared to the composting process, because composting process requires a lot of large land area, because aerobic composting is a slow process and it needs a lot of space. and the land time of anaerobic degradation process will be comparatively less. So that is the additional benefit of this. And another one is the waste treatment benefits. Actually, we'll be getting the benefits in terms of volume reduction. So whatever the bulky waste is there, after degradation, the volume will be considerably reduced. And this waste is also have another advantage, that is a potential for co-disposal with other organic waste. For example, co-disposal in the sense, for example, if we have put up an anaerobic digestion process treatment plant, we can use the vegetable market waste, we can use the slaughterhouse waste, we can use the fish market waste, all can be composted together. So this need not be a separate project, separate plant for each substrates. So whatever the waste, we can have a co-disposal, post-treatment is possible. So that is the advantage of that. And it have a lot of other advantages also that I'll explain in your subsequent slides. So when you come to the biodegradation, municipal solid waste, biodegradable organic fraction is about 50%. The organic fraction for municipal solid waste is about 50%. And the major comes from the kitchen waste, from the domestic activity, kitchen, hotel and restaurants, hostels and canteens, vegetable market, slaughterhouses, all other have these methods. And when you go for a treat improvements, actually, when you go for this waste, sometimes co-disposal, as I mentioned, if you mix this kitchen waste, vegetable market waste, all those combinations, there will be increase in biogas production. So that is the improvement techniques. And another one is the pre-treatment with azithromycin fungi. Actually, some of the waste like a vegetable market waste, we have a lot of fibrous waste which are having more amount of lignin and other things. So when you have waste having more lignin content, woody biomass, then it is better you give pre-treatment so that the biodegradation will be faster and also increase the biogas production. So actually, I mentioned about the co-disposal of the waste. It has when you mix the waste two together, you can have a synergistic effect. That means you have an additional benefit. For example, if you take a cattle waste, cattle manure, it is having only 0.38 metric per gas per kg of VS added. Whereas if you go for a pig farm waste, 0.569, pig slurry, that is pig farms, you get the waste, that is 0.569. So when you mix this together in equal ratios, what happens actually, instead of getting an average value, for example, if I take 1 kg of cattle waste and 1 kg of pig waste, I'll get 0.38 and 0.56 metric of gas per together. So when it mixes together and go for a digestion, that is co-digestion, then I'll get 0.51 per kg for each kg of that. That means there will be increase in biogas production of 7%. Similarly, cattle and poultry, there will be increase in biogas production. Cattle and sewage is also increase, 16%. Like that, we have when you go for a co-digestion of waste, it also increases the biogas production. So that is the added advantage of this because we have for any biological processes, we require the all the nutrients. For example, some of the waste may have lack some nutrients that may be available in the other waste. So there will be a mutual benefit. That's why it's called synergistic effect. We call it as a synergistic effect. So this is the advantage of co-disposal solid waste. And as I mentioned, the actinomycins to increase the biogas production. There are literature reported, different species are reported, which will increase the pre-treatment or treatment of the waste, especially the lignin-containing substances, that increase the biogas production up to even 37% or even 44% increase as we report. So that is the advantage of this pre-treatment actinomycins or any other fungal systems. So we have previously we have done one study long back, and where we have done a reactor with semi-continuous reactor with the kitchen waste and domestic sewage. And if it's a control system with the only kitchen waste was giving 0.22 meter cube per kg. And when you mix with the domestic sewage, it is increased to 0.430. So there is about increase of production of 32.7. This has been about 20 years before this has been proven. So that is one method by which we can increase the biogas production from the solid waste. And if we go for the bulk waste, I mentioned the bulk generators. So the bulk generators, as I mentioned, we have the vegetable markets where actually you get the fruit, flower. Even if you go to Chennai vegetable market, Coimbatore, we get the fruit, flower, vegetables, everything mixed together. So and we have the slaughterhouse waste also. And the vegetable market waste, as of now, they have a biogas plant, and they are getting about 150 tons of waste per day. And this waste, only part of that is treated in this biogas plant. 20 to 30 tons is treated in this biogas plant. It's a bulk biogas plant, and there they're able to treat partially. And other organic waste that is generated, as I mentioned here, is the fish waste, food waste, and other things. This is a bulk generators. So what we have done is in CLRI, we have taken a project. It's at the pilot level. We have put up a semi-commercial pilot plant where actually the energy of the vegetable market and the slaughterhouse can be improved. So we have done a project in that research project where actually the vegetable market waste, slaughterhouse waste is subject to co-digestion process and increase the biogas production. So that is the major objective. And as I mentioned here, the vegetable waste from the different sources. So we have taken the fruit waste, vegetable market waste, and the slaughterhouse waste. So this waste, actually the slaughterhouse waste also, why taken a slaughterhouse waste is, it's as of now, this is also dumped in the open dumping. There is need for hygienization because slaughterhouse waste may contain some pathogens. So there is need of treating it properly so that hygienization, that means bacteria contaminant pathogens also has to be reduced. And if you go for biological treatment of slaughterhouse alone, what happened actually, it has a lot of variations because we have a lot of, if you see the amount of waste generated. For example, if the animal slaughtered also, based on our eating habits, the amount of waste generated is also ununiform. For example, not uniform. Since Sundays and all, there will be around 2,000 animals are cut. In the weekdays, it may be only 100 or 200. So the amount of waste generated is very inconsistent. So it will not be possible to have a plan for that much variations in the waste field. And also, we also have CBN ratio, one of the important factors for anaerobic degradation process. The nitrogen content, because it's animal based, we have more amount of nitrogen from the waste, so that the CBN ratio will be very, very less. So it's not the optimum. So we can go for co-digestion with other waste. So that's why actually we have taken this slaughterhouse waste, and actually as of now, so much amount of animals happens on a live wave basis. We'll get so much treatment loss. We will not go into the details. This is the vegetable market, and anaerobic co-digestion in the most cases improves the efficient due to positive synergy system, and also co-digestion slaughter otherwise reduces the overall loading problems and improve the biodegradability because the animal waste mostly have the plant-based substances which are not easily degradable. So that can be improved by mixing with other waste. So that is our advantage. So as I mentioned, the Indo-German project, we have taken the industries, industry partner are also there, CLRI and Leibniz University from Hanover, and the Ramke from Indian side, and Lehman is a company from German side. So here what we have done is the waste from the slaughterhouse waste, market waste is collected, and anaerobic degradation is done. The pre-treatment is also done. Actually, pre-treatment also we introduced the novelty where we have introduced the bio-extruder, where actually the waste, normal waste treatment, what they do is a shredder. Shredder means just cutting the reducing particle size. Here we introduce a new type of pre-treatment where actually the there will be two screws in which the waste will pass through. It's called extrusion process. When it passes through that, the size reduction also happens. In addition to this, there will be the waste is subjected to high temperature and pressure. Because of the chemical composition of the waste itself, it changed, and that has a lot of impact on the biogas production. Then the waste is taken for digestion, and the stabilization of the waste is taken care of, and we get the nitrogen phosphorus from the waste that can be utilized. So other waste I was mentioning is the poultry waste. The poultry industry is also another one. It's a major waste created from that, and this already be covered. And this is with respect to the animal waste. This is a slaughterhouse waste, where actually this is slaughterhouse waste. This has been put up for a commercial slaughterhouse in Hyderabad, where actually they are generating about 3,000 meters of biogas from the plant. But there is no other source available for the mixing of the waste. Based on these experiences, we found that mixing of vegetable market waste and this slaughterhouse waste will improve the overall efficiency. So we have put up this pilot plant in our campus, and you can see here this is the waste collected, and it is actually this is a waste that is coming from the market slaughterhouse, and it's past the shredder. We have a shredder here. After shredder, it will be collected in this, and from here it will be pumped to the digester. You can see the digester here, and we also after the digester we have the monitoring system. From here it goes to the whatever the digestate that comes out will be collected here, and that will be taken to the further treatment processes. And whatever the biogas that comes out here from here, the system will be collected here, and it is as of now it is burned, and it will also have a provision to collect the waste balloon and scrub it. After scrubbing, it will be utilized for waste energy project. So that is the advantage of this project. And as I mentioned here, this we are using not only vegetable market waste and the slaughterhouse waste also. The ratio 1:3. So we have done a lot of lab scale experiments to optimize the ratio of vegetable slaughterhouse, and we have published papers on that. Based on that outcome, this is the you can see the overall view of this plant. So the waste will be collected from here, and it is taken to the first hopper, and the bottom we have the shredder. And after shredding, the waste will be collected here. We have at the bottom we have the screw pump. From here, it is pumped to this system. This is the bio extruder that is supplied by a German industry partner, and we have two screws in between. The waste will be passed through that, and after the extrusion process, it will be collected in this tank. From here, it is pumped to this biogas tank. From the biogas tank, we have a mixing arrangement. We have a temperature control, other things. And whatever the gas that comes out is we have online biogas monitor. We will measure the flow of biogas that is collected here. And whatever the gas that comes out is collected in the balloon, and it is housed inside this sheets. And this is how this pilot plant has been put up. And I'll show you a couple of this is another waste I was mentioning about this is another project where we are working with a German partner. That is on pyrosol. This is a thermal treatment method. Here, what we are trying to do is we are taking the dry fractions. In the vegetable market waste, what happens? Actually, during that process, vegetable market, you can see that vegetable market waste, we have a lot of banana pedangle. That is called, we have banana-based system, no? That is a Valatar, we call it as Valatar, center portion. That is a major waste that is coming from Coimbatore. That is about 20 to 30 tons of vegetable banana pedangle is coming out from the waste. That is actually fibrous in waste. In addition to that, we have a lot of coconut banana-based fibers and other things which are not suitable for anaerobic degradation processes. They will not undergo any changes. So that's why actually we have developed a thermal treatment method. That is another project we are working with the German partners, where actually we take the banana pedangle, and this banana pedangle will be first shredded first and dewatered. After dewatering, it will go to the another thing is what we have in this project we have included is in addition to the fibrous waste, we also taken the sewage sludge from the sewage treatment plant. That is the sewage sludge is a dewatered sludge, is also disposed in the landfill. So that is another solid waste. So we are actually taking the fibrous waste and the vegetable market waste, sewage sludge from the sewage treatment plant, and both will be combined together and dewatered in this mixing and storage system. And after that, is actually to reduce the moisture content, we are taking to the solar drying system, and the solar drying system. After that, it goes to the solar dried system is goes to the. So we want to design a natural solar drying process, and dried samples is taken to the pyrolysis system. The single chamber pyrolysis, this will be supplied by our industrial partners. And whatever the end product is the biochar. After pyrolysis process, we are not taking any oil in this system. We are taking only the biochar. So the biochar is collected here, and the biochar collected by biochar goes to the So this the fibrous waste, what we can do is so the fibrous waste, what they can do is this actually after drying it is taken to the pyrolysis system. In the pyrolysis system we get the biochar. The biochar can be taken to the field and this can be used as a soil amendment. Actually, this biochar has a lot of advantages. It has water retention capacity and also slowly release the carbon to the soil and other advantages. So this biochar can be a potential source of organic manure and also a potential source for the farmers. And whatever the energy that comes out from this heat energy, that also can be converted into electrical energy, or it can be used as a heat energy directly. Whatever the based on the requirement, we can try different methods and reuse it. And if required, this waste heat after utilization, if we convert electricity, if there is some waste heat, that also can be taken to the drying process. That is also possible. So the energy that is produced can be used for external uses. So that is the advantage of this solar drying and thermal treatment processes. So as I mentioned here, the vegetable market waste, slaughterhouse municipal solid waste, the organic fractions, wet fractions, especially the food waste, the slaughterhouse waste, the other things can be taken to the biological food with the pre-treatment for the German extruder. Then it goes to anaerobic degradation process, we get the biogas and slurry, digestate. Whereas the digestate, that other waste, that is market waste, banana peduncle and the sewage sludge is taken to this thermal route and the pyrolysis process, and we get a bioenergy and we get a biochar. So this is an integrated approach for managing the organic fractions of the municipal solid waste. And this actually, as of now, this anaerobic treatment biogas plant has been put up. The pilot plant, the demonstration plant is available on campus. And we are also going to put up another plant for this pyrolysis system that is also going to be taken up. So these are the advantages. When it comes to the industry, hazardous waste, when you come to the industrial waste, as I mentioned that we have hazardous and non-hazardous. So the hazardous waste, actually if it is having a calorific value, if you have calorific value, then it will be sent to the cement industry as a fuel. Or if it is not possible, then it will be sent to the incineration facility, even within the hazardous landfill facility, landfill treatment facility. And after incineration, whatever the heat energy is there, that will be trying to recover and reuse. And whatever the non-hazardous, if it is hazardous, not suitable for the cement industry and incineration process, then they'll send it to the landfill. And the hazardous landfill, and we're storing it. And in the bottom, you can see the landfill bottom will have a liner system, HTP liner. Over that, they put the waste, and they then completely close with the liner system, and they make a green cover on the top of the system. It's completely closed system will be made. That is a hazardous landfill system. When it comes to the other industrial solid waste, for example, if you have a plastic waste, so when you have a plastic waste, we can go for recycling, or we can go for construction materials. I think a lot of works have been done on the making plastic waste into construction materials. That has been done. So this construction waste, or even also it has been plastic waste, or to some extent also have been utilized. Construction, road and pavement construction, all works also has been taken up with the plastic waste. A lot of work has been done on this aspect. So the plastic waste, if we can segregate the waste, it also can be very well utilized. And for example, if you go for some industrial waste like fly ash from the thermal power plant, then this fly ash is a potential source as a construction materials. Nowadays you might have come across a lot of fly ash based bricks, fly ash based materials, pavement blocks. A lot of things are coming up with the fly ash as a raw material, construction materials. Then we also have come across something called the geopolymer concrete. Geopolymer concrete, actually they use a fly ash as well as the another solid waste from the steel industry, blast furnace waste, GGPS, they call it GGPS. So that they'll be mixing it, and without a cement, they make a concrete. That's called geopolymer concrete. So that there actually the fly ash is used. So geopolymer concrete based materials also can be developed using the fly ash, and the fly ash also can be used for filling in many of the areas and other places also. That is a potential use where which we can manage that. And as I mentioned already, the biodegradable portion to as a biofuel, anaerobic degradation process or thermal heating methods, as I mentioned earlier. And if you have some material which is having a long life, then you can also think of having building materials. And the composting process, if it is biocomposting, we can also go for other organic manure you can get out of. And overall, this is for the wind energy. So if you see that actually this is the sustainable development goals. Actually, if we go into the sustainable development goals, we can see the solid waste management, what it affects. Actually, this is the major goals in which we all have to work in this decade for the sustainability of the globe. So here, actually, you can see that if you go for proper solid waste management, you can see that there will not be much poverty. Actually, the poverty also can be reduced if you go for a recycling. Recycling means if you make the solid waste management at the local level, instead of making as a centralized facility, if you make a decentralized facility, then a lot of opportunities can be created, which can be utilized for generation of what you call this entrepreneurship concepts, where actually the poverty can be reduced, and to some extent even the zero hunger. So wherever there is no, we can make some employment or recycling opportunities. Then these two can be taken care of. No poverty, there will not be any poverty, as well as the hunger also can be reduced to the major extent. So that is the other advantage of this solid waste management system. So we have to go for a decentralized recycling facility which will handle this. And if we avoid waste generation, and also if we go for a proper sustainable method, we will be able to maintain the good health and well-being. That is for the general public. And quality education will be able to make gender equality. Here also the opportunity can be provided for provided to all the people for especially the human folks, so that they'll be able to handle the waste in the proper manner, and also it will be contributing to the again no poverty and zero hunger. So that is the advantage. So we can handle this also goes along with the no poverty and zero hunger, and clean water and sanitation. So whenever you have a waste, lot of waste dumped on the landfills or open dams, if it is not properly handled, it affects the groundwater. So the groundwater will be the main source of water source for many of the people. And the sanitation condition on the particular location also will be completely affected because of the sanitation. If you go for what you call the improper solid waste management. So if you go for a proper solid waste and with the segregation at source and proper decentralized waste management, very well we can manage the clean water. So that will not be affected. So all this, the proper management of solid waste leads to a lot of meeting the development goals of the sustainability index. Affordable and clean energy. As I mentioned here, this is one of the greenhouse process. The advantage is the major source of pollution is climate change effect is coming from the urban transport. So in the urban transport system and as well as the industries, we can use this hazardous waste as well as the organic biogas. Biogas from this is as a bio fuel. So when you use this biofuel, and if we use that energy, the amount of emissions will be considerably reduced. So this will be and also affordable. that is the advantage of that. So this has a lot of effect on the environment. So another one is decent work and economic growth. Satish, decent work and economic growth. This will be added advantage of the sustainable waste management works. So when you go for a industry innovation infrastructure, this industry innovation infrastructure also, most of the industries, if they go for innovative methods, this also will be addressed to major extent, because the industries are utilizing the solid waste from the municipalities or other industries as the raw material. So automatically they'll be using the proper fuels or efficient methods, and they can also use innovative methods. Innovative methods and infrastructures. So this also, to some extent, if they use a proper solid waste management, that also can be taken care of. Reduce inequalities, that is also possible, as I mentioned. Sustainable cities and communities. This is very, very important. Actually, sustainable cities, most of the cities actually facing problem with respect to the municipal solid waste. So many of the cities, actually, the major amount of waste, that is major amount of financial is related to the solid waste. Especially, they make a lot of investment on the solid waste management, and most of the investment is also going for only the transportation of waste. And the sustainable waste management is a main part of the problem. And if we go for decentralized and sustainable waste approaches like this biogas for the organic fractions, and also for the vegetable market waste, other things, we'll be able to get clean energy. Also, the cities will become very sustainable. That's why actually many of the European cities, what they do is actually they go for two systems. They wet fractions. Wet fraction, they go for biological treatment method. For the dry fraction, they go for the incineration. So both the methods, they reduce the volume drastically, and the incineration, they get the electrical heat energy, and the heat energy is converted for heating purposes, or it's directly converted electrical energy, and it is used. And in the wet fraction goes for thermal biological treatment processes, and they get the energy out of it. And whatever the digestate that comes out is also utilized as a biomenu. So they ensure that most of the cities follow this method, and it is the waste is properly managed, and the maximum amount of energy is also produced from that. So that is how they are trying to maintain the sustainability within the urban area. That is sustainable cities. And whatever the projects we have taken up at the Indo-German, the second project, the pyrolysis, is also addressing main objective of sustainable cities or smart cities in case of in our country. In our country, we are also working on smart cities, so that our smart cities also can handle this waste. Responsible consumption and production, especially this is very, very important, because the solid waste generation is also one major issue, and whatever is ultimate, what you call as the treatment strategy is concerned, wherever is possible, you have to prevent it. So the prevention of solid waste is the first strategy. Then reduce the amount of solid waste. Then we have to go for the treatment process, then disposal. And disposal also, we have to recycle wherever. For example, the fly ash is a solid waste that can be recycled as a construction material. And we have the vegetable market waste that can be used as a manure or a substrate to the biogas plant. Like that, we have to find some consumption and production patterns by which we'll be able to recycle the nutrients and other energy potential of that. That is how we should plan for this solid waste management. Climate action, very well. Actually, as I mentioned, I showed a lot of slides about the impact of climate change and how the climate change is affecting the solid waste is affecting the climate change. Actually, we can say major amount of the greenhouse gas emissions, around 30%, 25 to 30% is coming from the energy sector. And in the energy sector, if we can replace partly with the waste, this will reduce it drastically. And also, if you see the transportation sector, especially the public transport, is also another sector which is also contributing for the greenhouse gas emissions. If you select other waste like what you call as this biogas based transportation system, then we can reduce a lot of impact on the environment. So the climate action has a lot of the solid waste have a lot of impact on the climate. And life below water, that is below sea, where if we can properly handle the waste, if the waste doesn't reach the sea, to that extent, we are saving the environment. You might have seen a lot of plastics and other things going to the sea, and a lot of animals fishes are dying because of the plastic and other waste that is disposed on the sea. That have to be taken care of. So when you have a proper solid waste management, we can ensure that there is no solid waste going to the sea. Life on land, especially the birds, trees, everything can be saved if we have a proper solid waste management facility. If you don't have open dams and other things like that, you can take care of the life on the environment also with the proper solid waste. And the peace, justice, and everything is also taken care of. And strong institution partnerships and partnerships for goals. For example, the corporation alone cannot meet. The corporation, NGOs, the community, everybody has to work as a partnership to achieve these goals. I think solid waste to out of the 17, I think most of the issues, all the 17 SDGs also can be addressed by the solid waste, and we have the role played by the solid waste management is very, very important. And everywhere, not only starting from poverty to partnerships, everywhere solid waste management has its contributions. So the solid waste in the city is very, very important, and this has to be managed, as I mentioned, proper segregation, and organic fraction should go for the thermal route or biological route, depending on the moisture content. If it is a moisture, if it is a biodegradable, we can go for a biological route. We can get biogas from that. And if you go for a non-biodegradable portion, non-biodegradable in the sense it's a biological material, it is not suitable for anaerobic degradation process, then we can go for solar drying and incineration or pyrolysis, by which we can get a electric energy from that. That is how we can manage both the organic fraction with a safe manner. So if you have any questions, with that I'll complete my presentation. I would like to thank my director and head of the department, my research scholars, for and funding agencies, my industry partners for this projects and the activities which we have presented here, were contributions from these people. I would like to thank the organizer for giving me this opportunity, and if you have any questions, I'm happy to answer.
Thank you, sir. Thanks for your excellent presentation, sir. And we have got few questions from the participant side. One question, how can municipal solid waste be treated using earthworms? The question is posted by a participant, sir.
Yeah. Actually, this solid waste, as I mentioned, we have about the composting process. The vegetable market waste, organic fractions can be treated in the biological treatment method. So here, the composting process also one of the method. In this, they were called the vermicomposting. So vermicomposting, there where they use the earthworm. So when you have an earthworm, so there is the organic waste can be shredded into small pieces, shredded, and it can be in the household also we can do it. This type of system we can do it in the household activities. Whatever the waste that comes in, we can dump in a container, and we can put some few earthworms. So what happens actually, earthworm will eat all that solid waste, convert it into compost. So that actually is a faster process. If you go for aerobic composting, it will take some time. If you go for vermicomposting, it will be very fast. So that is possible. So that is one method of doing it. That is possible. We can go for vermicomposting.
Thank you, sir. Thank you, sir. Next question is, how to manage household solid waste? This is another question from a participant. How to manage household solid waste?
So the household solid waste, actually, we can segregate it. For example, if you have a plastics, we can collect it, and we have a paper waste, we can collect it. And if we have any other organic waste, and if the organic waste, actually, we can go for household we have now nowadays a lot of companies are offering company-based, small household-based biogas systems also. So that also we can do it, and if they have enough space, they can collect the papers and plastics and other things separately, and that can be given to the recyclers. And the plastic can be recycled, and the paper also can be recycled. If they have any other organic waste, then they go for household biogas systems. There they can go for their own biogas facility, and whatever the gas that comes in also can be utilized in the kitchen itself, so that we can manage the waste as well as we can utilize it for our kitchen heating purposes.
Thank you, sir. Thank you. Another question from Dr. Praveen Sukraj Bandari. What type of solid waste management technique you will recommend for thermocol?
Thermocol, actually, thermocol, there are new methods by which we can be converted. We have some solutions where it will be completely absorbed. So there are companies which are manufacturing thermocol. So what they do is actually they use initially for the preparation of thermocol, they use the beads, plastic beads. So that plastic beads, if you give this material itself, thermocol, they're ready to take it up, and they have some solutions also by which it will be absorbed and converted small pieces. I think even our sister organization, IACT, and other organizations have some technology by which they can convert into absorbed. That is, it's a bulky material. No, once all that bulky nature will be reduced and it becomes a solid material. That solid material can be utilized for other applications.
Thank you,
Or
sir.
it can be also recycled for even making the thermocol again also. That is also possible.
Thank you, sir. Another question from Gajanan and a team. How to choose the replacement method when using the solid waste, ceramic tile, concrete waste, etc., as the alternative material?
This ceramic material, I'm not sure about this. Actually, the question I'm not clear. Whether it is
Can I
talking
repeat the
about
question, sir?
yeah, please.
How to choose the replacement method when using the solid waste, in the bracket, ceramic tile and concrete waste, as the alternative material?
So what I mean, I understand is actually he is looking for utilizing the solid waste in the concrete. So the solid waste, the potential solid waste that can be utilized in the concrete or tiles is the insulated ash. Even the ash that comes out of the incineration facility, actually after the solid waste treatment, we get insulated material that can be utilized as a construction materials in the cement or tiles, so that it will get completely fixed. So even if there are any heavy metals, that will not be leached out, it will be completely immobilized. One method. Another method, if you want to use that concrete and the tiles, the broken tiles as a waste, if it comes from the C&D waste, we call it a construction demolition waste, then that can be actually, as of now, there are now methods by which we can also convert the construction demolition waste into reduce the size and pre-treat it so that it can be used as a aggregates in the road construction or any other construction also is possible. So both the ways it can be taken care of.
Thank you, sir. Another question from J. Parthiban. How much amount of vegetable waste we can process at a time?
So that's not a problem. Any capacity, based on the capacity, we can design it. For example, if the vegetable waste is for a small town is so much quantity, we can design for the particular capacity. There is no need of, there is no issue on that. So depending on the capacity, we can go for different design, and the plant can be designed for that. And if it is very big, we can go for a modular basis also. So that is not a issue. We can go for any capacity.
Thank you, sir. Another question from Sunita. What is the capacity and cost of treatment plant that is installed at your campus, sir?
Yeah, this plant, what we have designed is about 0.5 tons per day. This actually, as of now, this cost about, without our German partner contribution, that is a pyrolysis extruder, it is about 80 lakhs. It is for 500, but actually our system is a little sophisticated in the sense because we have put a lot of online monitoring system and other things. That is not required for a full-scale plant. For example, this as it is a research project, we have put up a lot of online monitoring systems, temperature control, pH, ORP, all those things which may not be required in a normal plant. We can go for a daily monitoring. We can collect the sample and monitor the pH with the help of a pH meters. So that is not required. So what we have put up is a little expensive because it's R&D plant. We have put a lot of equipment, monitoring system in place. So that is not required. And actually, the bio-excluder what we have is about that alone cost around another 80 lakhs. But actually, this is little bigger capacity. This can handle actually 200 kg per hour. That was the smallest capacity that is available in our industrial partners' sites. So that's why we have to take that plant. But if we go for a full-scale plant, this very well it can be properly designed, taken care of.
Thank you, sir. Thank you, sir. Another question from Pratibha Gautam. Please tell about management of sanitary waste. Currently, we don't have system to manage that.
Sanitary waste, I don't know exactly. Maybe she's talking about sanitary napkins or something like that. There are actually now systems to incinerate the napkins that are available. And now actually many companies, small entrepreneurs have come up with new concepts where actually they can be incinerated safely. In, most of the schools and other things now actually they have been asked to put up these facilities so that this can be taken care of separately, individually, at a decentralized level.
Thanks, sir. Thank you. Then another question from Kottapalli Gurulingam. Why vegetarian concept is not being promoted as major chunk of waste come from non-vegetarian food?
I don't know exactly what he means. It's vegetarian waste. So whether actually it's vegetarian, non-vegetarian, it is the waste that comes out has to be handled by the municipality. So the vegetable waste, and if I am just doubting whether he is asking why you are mixing the slaughterhouse waste and vegetable market waste. I don't know. Maybe from that point of view, he is asking.
Okay,
But actually,
yeah, probably, sir. After completing this question, I'll ask him to ask the question directly.
okay,
We'll complete the remaining questions put forth. Yeah. Then probably we'll give him a chance. Then how can we store municipal organic solid waste before anaerobic digestion process? This question from Gajanan and team. How can
actually,
yeah, please, sir. Go ahead.
this waste actually, this anaerobic degradation process. So there is no need of storing the waste. We can collect the waste immediately, feed it. Actually, this it's better if you collect and feed it immediately. So the fresh waste is better. If you store for a longer time, that will be difficult. So what I would suggest is wherever is possible. That's what actually we should have planning in the sense whatever the waste generate, wherever it is generated, within that maybe distance of 5 kilometers or 4 kilometers, we should have a decentralized facility so that the waste is taken immediately to the facility and fed to the digester. And that should be the way. We should not store it for long duration. If we go for a long duration, what happens actually? It gets putrefied as well as it get liquefied also. You get a lot of liquid in the handling. So if you handle as a solid waste as fresh, it's better. So it will avoid your water issues and other problems also.
Thank you, sir. Thank you. Another question from Ramesh KV. Please explain about CBG process.
CBG.
Yeah.
CBG, that is he's talking about calorific value, gross calorific value.
Yes, put just CBG.
CBG. CDG, CDG.
Yeah, ABC, CBG.
I think construction demolition.
Yeah, another CBG micro level possibility, please.
I think micro level composting maybe. Micro level composting. I think now most of the municipalities have taken up this.
Compressed biogas is talking about. Please explain.
Compressed biogas.
Biogas.
Okay.
Yeah.
Yeah, actually, the concept is very good, and in European countries they are doing it very well. But only thing is, we should have enough capacity. For example, if we go for compressed biogas systems, then we should have enough capacity. For example, if you go for 2,000 meter cube per day of biogas, then it becomes economically viable. So if you go for lesser capacity, the biogas composition, the biogas volume, then this becomes uneconomical. So if you have a biogas generation about 2000 metric cube per day, then very well it is possible to go for a compressed biogas system, and that is economically viable. So if you go for a decentralized system, then it will be not be suitable. So that is the disadvantage of going for a compressed biogas system compared with the municipal solid waste. So if you have a centralized system and if you have 2000 meters of gas per day, then we can very well go for a compressed biogas system.
Yeah. So one more question from gentleman Parthiban. Is it possible to feed 300 metric ton of vegetable waste per day?
Yeah, it's possible, sir.
Possible.
You
Thank
can
you.
design, yeah.
Yeah, and yeah, let me check for direct questions from participants, sir. Let me see the hand raise. Somebody have got questions, you can raise your hands so that you can talk directly to the presenter. Yeah, that is fine. So one more question. Can you throw us, explain us a little bit on, see, in tanneries, disposing the hair, like, the goat hair, the cow hair, it's a big problem for them. How do they handle it, sir? Is there any technological innovation on disposing the hair or controlling it in a better way? Anything is available right now?
We have now some method by biological methods. We have some biological methods, enzymes, where it can be completely dissolved. So that is what is some works have been done, and some if it is ship based materials, if the hair is lengthy, then they try to go for recovery and potential reuse of the hair as such. If it is smaller in size, they go for the dissolution process or cooking process. They completely dissolve. So that is how the hair is managed in the tanneries. And
Okay.
tannery also we have actually I have not covered to the maximum, but some extent this is a tannery waste also we have some organic waste like flushing. Flushing is a waste which will have a lot of potential for bioenergy.
Okay.
So because I am taking mostly mixed solid waste and hazardous waste, and I mentioned in the industrial waste there is something called non-hazardous waste. So, for example, some industries like the leather industry, we have a solid waste flushing. It is non-hazardous. It is not having any hazardous chemicals and all. So this can be mixed with the other vegetable market waste also. This can be digested along with the market waste or any other organic fractions also, and it can be treated anaerobically, and the biogas can be produced from that. So that is possible. Actually, we have did a lot of work with flushing waste as a biogas plant. That's why actually from that only we came into this municipal solid waste.
Okay. Okay. Thank you, sir. Sir, Dr. Shilpa Sharma, if you have got a question, you can ask to the presenter. Let me check for some other questions. Yeah. Okay, so no more questions, sir. Sir, thank you so much, sir. You threw us a light on solid waste dumping. The overview, what it gave on solid waste management was really, astonishing. And a lot of ideas you threw up to the participant. And you explained clearly about the innovation, the projects, what you take through, the new projects, what you're handling with. Thanks for it, sir. And particularly, you explained about sustainable development goals and what is the role of waste management, managing the waste, in achieving all the 17 levels of sustainable development goal. It was an eye-opener, hope for everybody, all the participants. And fly ash, the uses of fly ash. Then you explain about municipal solid waste, slaughterhouse waste, and particularly you explain about the pyrolysis process. India, it's you're slowly getting into pyrolysis process. So that's an eye opener to all of us. Thanks for your time, sir. So you spent your we could understand your busy schedule. You have been frequently disturbed by your people. Yeah. Even then, you could manage. You spend you are spending time with us. Thank you so much for that, sir. Once again, Thank you all the participants, and
Thank you.
for this nice session, sir.
Thank you, sir.
Thanks, sir. Thanks, sir.
Thank you very much.
Thank you, sir. Dear participants, yeah. So we end the 6th session, no, today, and tomorrow morning again, the 7th session will start exactly at the stipulated time, 10 o'clock. I mean, like your feedbacks questionnaire and the attendance question will be posted to you. You can now post your details there in the forms, which will be posted to you. Thank you all for your patient listening. Any questions? Yeah, kindly post in our group. Yeah, it will be done. Thank you. Thank you, sir. Thank you all the participants. With this, we end up this session. Thank you. Thank you.